So this is video number 2 in the series of 3, and this one's about actually forming the ionic compounds. So in the video 1, you learned how to name them, and as you practiced on the worksheets in class, you saw that they were fairly straightforward. You know, you take name 1 plus name 2, and you're done. Now, the forming of the compounds is a little bit more complicated. So let's start simple, and we'll work our way more complicated. So let's start with lithium bromide. So we're going to go to our ion chart, and we're going to look up lithium, and we're going to look up bromide. So we'll see that lithium is Li and bromine is Br. Now we have to add their charges in. So lithium has a charge of +1 and bromine has a charge of -1. Now you'll notice on the chart the ones are not written. Like I said in the first video, we don't always write ones. Sometimes they're inconsequential. So, but I need the ones here for the purposes of the video. So this is how we're going to form the compound. You'll notice that when we make compounds, there's always those little numbers that are down below, and this is going to show you how to make those numbers down below. So this is a method I call crisscrossing the charges. And what we want to do is we want to balance the positives with the negatives. So what we're going to do is we're going to take the 1 from the bromine, and I'm going to bring it down as the subscript on the lithium. And I'm going to do the same thing with the lithium. Take the 1 on the lithium and bring it down as a bottom number, a subscript, on the bromine. Now, whenever you've seen a compound written before, you'll notice there's never positives and negatives written anywhere. So we're going to get rid of those positives and negatives right now. And you can see that my compound is now Li1, Br1. But because in chemistry, ones are not always necessary, we're going to take them out. And that's the compound. The compound is lithium bromide, LiBr. So if you didn't understand that, go rewind, watch it again, and I'm going to move on to the next example. So let's talk about iron 2 chloride. Now, what's that Roman numeral doing? Well, you'll notice that on the chart, the Roman numeral tells you the charge of the ion. So iron 2 is iron with a +2 charge. Chloride, when you look it up on the chart, you'll see that it's Cl, and it's Cl with a -1 charge. So it doesn't really matter what the charges are. The process is exactly the same. So I'm going to take the 1 of the chlorine and bring it down next to the iron, and I'm going to bring the 2 of the iron down next to the chlorine. And again, the positives and negatives disappear. We only really move the numbers. So we make those positives and negatives go away. And again, on iron, because ones aren't important, because if it's written, it must be at least one of it, we're going to make the 1 go away. So iron 2 chloride becomes FeCl2. Now again, notice that the 2 on the iron, the Roman numeral 2, doesn't tell you that there's 2 irons. It tells you that iron has a +2 charge. Okay, let's look at sodium oxide. So sodium is a +1. Oxide from the bottom left-hand side of the chart is -2. So again, I'm just going to keep repeating the process over and over again. If you understand this, you may want to jump ahead to a more complicated example. So the 2 of oxygen comes down next to the sodium, the 1 of the sodium comes down next to the oxygen, the charges go away, and the 1 goes away, and boom, you have Na2O. Simple, right? Okay. Now let's do something with big numbers. So we've done stuff with 1s and 2s, well, let's add nitride, which has 3s. So strontium is +2, nitrogen is -3. Process is still the same. I'm still going to take the charge of nitrogen and bring it down next to the strontium. I'm going to take the charge of strontium and bring it down next to the nitrogen, and I'm going to make the charges go away. Now, in the previous examples, they had 1s, and the 1s disappeared. But here, because there's no 1s, all the numbers stay in place. Okay, now, that's great when you're dealing with what are called binary compounds, meaning there's only 2 elements involved, like Na and Cl, or Sr and N. But what happens if you have something like from the right-hand side, which is actually a polyatomic, poly meaning more than 1 atom. So here's the case of nitrate. So you have Ca, calcium, which is a +2 charge. You have nitrate, which has a -1 charge. Now the process is still the same. We're still going to crisscross our charges. So I'm still going to take the 1 of the nitrate and bring it down next to the calcium, and the 2 of the calcium and bring it down next to the nitrate. But the problem is, if I just get rid of my charges like I did previously, the nitrate kind of looks like NO32, which is not right, because I don't have 32 oxygens, I have 2 NO3s. So what I'm going to do is I'm going to get rid of my charges like this, and I'm going to put the NO3 in parentheses. Okay, so now you can see that 2 outside the parentheses is actually telling me that there's 2 of everything inside. So I have 1 calcium and 2 whole nitrates. That's actually about as complicated as it gets at that point. So now what I want you to do is I want you to go to the ion worksheet and start practicing your ions over and over again. I think there's about 40 of them on there, so get good practice on them.